then someone wanted to read us what they had for 21. What did you have for your two equations in 21? Because these were all asking us to graph them. Noah, what do you have? 21? Do you have your two equations on that homework that we're handing in? So, this is in your notes that you're writing these. In your notes for D3. So we're going to just put these three equations going down. Georgia, what do you have? Did you find it, Noah? No? Georgia, what do you have?
Y equals 3x plus 20. And y equals 5x.
Okay? So, these three equations were really good for using this method called substitution. They were kind of, 20 was okay to graph in our assignment because you had nice y-intercepts of 3 and 4. But a y-intercept of 30 and then 0, y-intercept of 20 and a y-intercept of 0, those were ugly to graph. They had to be very spread out. So the question we're looking at in substitution is this. First off, what is substitution? Here are some basics. You remember in elementary school when you started out, you might have said a star was 3, then what is star plus 6? And you would have said, oh, well, that's 3 plus 6, which gives us 9, right? Well, now we get into the algebra part, and you did this in pre-algebra last year. M equals -2, and it says, well, what is M plus 5? Well, you substitute it in for M, just like when we do our checking. You plug in -2 plus 5, and you go, oh, the answer is 3. And here it says, oh, this circle is 4, and this pentagon, if we're looking at it, is -1. So what are these two things going to be when we add them? And we would have had 4 plus -1, which is still going to give us 3. So, if we are looking at this, it says, what grade were you in when you first did the problems like this? If you think back to these problems, you probably were actually doing substitution back in about first grade, maybe even, right? You were looking at this, maybe second grade, maybe some of you were even looking at combining two things together when you said, oh, this stands for 4 and this stands for one thing, and you put them together and said, oh, I have to have 5 apples or 5 whatever you were looking at. So you have been doing substitution for quite a while. It's just that you haven't seen it in a system of equations, okay? So I want you to leave these because we're going to come back to these three questions as we go through this unit and do our notes, okay? So if I am looking, and I want to look at this next part down in our notes, this kind of looks like the problem we just put up, number 19. Y equals 3x. No problem, they don't need to be done. And then x plus y equals -32. And it says, draw a star in place of the y's. So if we think of putting a star in place of our y's, I want you to do that. So we're going to put a star here, right? And I'm going to replace this one with a star, right? So if I am doing that, it says find the isolated variable, okay? That means if we are looking at this, it says substitute y equals usually or x equals. Which one do we know? In this case, we knew y was equal to 3x's. So if I am doing that, instead of writing x plus y equals -32, I'm going to write x plus, what is my y equal to up here? 3x. Write this the same with me. Some of you aren't with me writing, and when we look at your notes, they're not great. You have yours? Okay? Kayla, you want to do me a favor and shut the door? Yeah, we're turning both.
Oh.
No problem. You could have done it with the graphing cup there. Okay? So, if we are looking at this, it says now solve that new part of the equation. Well, this is a coefficient of 1, so I have 1x plus 3x, which gives us 4x, equals -32. If I'm solving for x, I divide both sides by 4, and I get x at this point is equal to -8. Okay. I have gotten one of my solutions. Remember, when we have a system of equations, we are looking for our answer to always be an ordered pair. So our answer always has to be parenthesis x comma y. We have just found, in this case, x is negative 8. We need the y. As you look back at your two original equations, so if we are looking at your two original equations, which one looks easier to substitute in and find what y equals? The first one or the second one? Which one of these, as you look at it, looks like an easier one to substitute in and plug in and say, okay, if x equals this, what is y? First or second? Y equals 3x or x plus y equals negative 32? I think the first one, y. So if we're substituting your answer into one of the originals, that's what we're doing here in step 3, y is going to equal 3x. But we're not going to use x. We're going to put y equals 3 times, what was x? Negative 8. So y is equal to negative 24. Once you've solved the problem, you want to do a check. You cannot use negative 8 in 24 in the first equation, right? Because we know what makes this first equation true. This was the first equation that we used. So when you check, you must use the other equation, okay? Use your other equation. Sam, right now I just want you to do this. You can check for your homework later, okay? I just want you to write this with us, okay? So if we're using the other equation was x plus y equals negative 32. And to do the check, you're replacing the x with negative 8. So I'm going to plug in negative 8 plus my y is negative 24. And the question is, does that equal negative 32? And negative 8 plus negative 24 does equal negative 32. It's a check. Okay? So, on the top of the next page, unlike our ones that we had yesterday in 19, 20, and 21 that we looked at, these questions do not have one variable equal to. So it says, is there an equation? The first step, look for an equation that has just the y. No. Do we have first or second equation that only has a positive y in it? First or second one? Does the first one have just a one y someplace in it? No. Then. So what's the coefficient of y here? The coefficient of y is 3. What's the coefficient of y over here, of x? So if we're looking at it, Noah, what's my coefficient of x? Is 4. If I go to the next equation, what is my coefficient of x as I look at that, Sam? Negative 2. What is the coefficient of y, Georgia? 1. This equation, is there an equation that has a y or x equal? At this point, no. Is there one that just has an x or a y? Yes, this one has just a y, right? So when we look at this equation, this one has just the y and it's positive. We're going to write down that equation. So when you start your homework, you got to have both equations. You're going to put 2x, negative 2x, plus y equals negative 3. We need to get y by itself. Carly, if I want to solve for y, what are we going to do? We're going to add 2x. Both sides of our equal sign. We cannot add these. They are not like. And my new equation for y would be y equals, and I don't care if you put 2x minus 3 or negative 3 plus 2x. This is my new equation for that second one, okay? These two are equivalent, right? They're just written a different way, right? This is standard form. We now have it in slope-intercept. It now says substitute the y equals into the other equation. So I want you to write the first equation down. Yes, this will take you many lines in your homework to do. You do not want to write down just each problem and think that you can possibly get done in maybe 2 lines of showing your work. It says replace the y value here. So what I sometimes will have students do is I'll say, okay, as we look at that, actually put the y in parentheses, because that's what we're replacing, and put in what you're replacing, right? So this is what y is. So if I'm writing that, Ava, I'm going to put 3, and then what was y equal to originally that we just found? So I'm going to put 2x minus 3. I still write the rest of the problem, so I still have plus, and I still have 4x, and I have 14. The reason we have to replace it is we can never solve an equation with 2 unknowns. But if we only have 1 variable, we can solve that. This goes back to what we did in the very first unit of algebra, unit A. We're going to use distributive property first to get rid of my parentheses. So 3 times 2x gives me 6x. Minus 9 plus 4x equals 14. Grace, next step in solving, you do what?
Add like terms.
Add like terms. So tell us specifically.
6x plus 4x.
Yes.
10x.
So we get 10x minus 9, right, is equal to 14. Next step, Avery.
Divide.
Not yet. I got to get 10x by itself before I can do that. So we're going to add 9. When I've added 9 on both sides, I get 10x. In this case, Kaylin, is equal to
25.
careful, 23. And now I'm going to divide both sides by 10. And my x value is equal to a decimal 2.3. Oh man, I don't know if I did that right. I have to go back into one of the original problems. So make sure, step 3, you do not go to this first one that you solve for, because some of you will make like a fatal error in that first mistake. And so you want to always go back to the original. So Lauren, which one do you think looks easier, the first one or the second one, to put in our new value of x? And because it really doesn't matter. Which one do you want to use, first or second? I'm going to let you choose. The second. So we are going to write that second equation. So we're substituting into our original, negative 2x. We're going to put a y, and we're going to put negative 3. But now instead of x, we're replacing it with 2.3. And then we're going to plus y equals negative 3. I would have used this one too because it is less multiplying and adding and subtracting. We get negative 4.6 here, right? Plus y equals negative 3. AJ, if I want to get y by itself, what do I need to add to both sides? I'm going to add 4.6. My solution for y is going to be 1.6. We write our answer. 2.3 is my x. My y value is 1.6. Do you see why we wouldn't want to graph this equation? It kind of looks like it could be a decent one to graph, because the y-intercepts probably aren't that bad. But this is why we can't graph it, because our answer does not come out as nice integers. And I know there's some of you that are checking everything anyway. So you look at this and you go, oh man, there is no way we could get these decimal answers. So we do the check. And we can't use that second equation that Lauren used. You have to go back to the first equation, right? So even if you want to do the check up here by it, so we already know our answer is 2.3, 1.6. We can go here and put 3 times, and if I'm substituting in, tell me, Ryan, what would you put in place of the y? What did we find y to equal?
1.6.
So I'm going to have 3 times 1.6, and definitely use your calculator when you're doing these. Plus, we're going to put in 4 times, and if I'm looking at that, Reese, I'm going to have 4 times what? 2.3. And now put that in your calculator, and what we're trying to see is, does this equal, question mark, does this equal 14? Okay? You plug it in, and it works, and so the answer that I'm looking for is the ordered pair. You cannot You do not want to just say, oh yeah, this is the answer. This isn't the answer. That was just your check. These two values were your solution, and we always want to write them as an ordered pair, okay? So, we want to look at a couple more that you're doing. Because we have special equations that come up just like where we had graphing, where we had parallel lines and we had no solution, and we have infinitely many. So, if we are doing this, this is what my x equals. I want to put this in a parenthesis because I'm replacing this whole thing is going to be my x. Here, this is my y value. I'm replacing y with that whole value. Now, does it have to be in parentheses like that second one? Probably not. But the first one, definitely, because you have to use the distributive property. So I put in 3.5 times negative 2y plus 4. I'm going to keep going with the rest of the equation, which was 7y plus 7y, and then equal 14. So everything else stays the same. The only thing that changed was I replaced my x. And you want to distribute now. So negative 2 times 3.5 gives us negative 7y. 3.5 times 4 plus how much? Plus 14. Plus 7y equals 14. When I add my like terms, I get 14 equals 14. If you get the same numbers equal to each other, our solution is all real numbers. And usually what we put, when we talked about all real numbers, if we're talking about, in this case, it was all real numbers. When we talk about what's our solution set, this is when we say that our solution up above is going to be infinitely many numbers. Solution is infinitely many solutions. Okay? So we're looking at it being infinitely many if it's true. Okay? Versus when we do this one and we plug in 3x minus 11, minus 3x equals negative 13. When we add our like terms, we get negative 11 equals negative 13. That is a false statement. If you would have graphed these, you would have found that they were parallel lines and there is no solution. Okay? We will, when we come back from lunch, look at, if we're writing x equals, what do you want it to be? New. X is new, y is our old video, right? Or the old games, okay? You pay $22 and you rent 6 games. And they're telling us the cost of each. So, first thing, you want to think of your first equation as being how many you rented. Do we have any idea how much of either one we rented? We know that the two have to total 6, so it either has to be like 2 and 4, or 4 and 2, or 3 and 3, or 1 and 5, or 0 and 6, right? So, x plus y equals how many games? 6. First equation. The next equation, so when you do your equations and you're looking at the story problems, the next one deals with the value. This first equation is in which form? Standard. The second one with the value of each game is also in standard form. What is, as we look at that, Addison, the value of a new game? How much is it worth?
4.
4x
Plus 2y equals 22.
equals my 22. So the value, like in this case, the dollars. Those are my two equations. So I'm looking at these two and I'm thinking, is there one variable that'd be really easy to solve for, either an x or y? Because neither one of them tell us what x equals or y equals. So we gotta pick one. Okay? Anyone have a choice? Solve for x or y? Sam? No, just tell me, solve for x or solve for y in the first equation. What do you want to solve for? Do you want to solve for x or do you want to solve for y? Okay, we're gonna solve for x. So if I get x by itself, my new equation would be x equals 6 minus, I'm not sure where you're getting a 5 from because there's only 6 and x in this equation. 6 minus y. Agree? Because what we are looking at when we look at this equation, to get x by itself, you had to subtract y from both sides. Okay? Put that on there because this is our new equation, and we are now using this and replacing our x. What did we just say x was going to be, Noah? What did we just solve for x to equal? I'm going to replace this x, instead of putting x, I'm going to put 6 minus y. I'm going to add 2y, and it equals 22. Use your distributive property now as you are solving. So you have 24 minus 4y plus 2y equals 22. I have some people say, oh, I'm going to subtract 24 instead of adding my like terms. Can you do that right away? Yes, you can subtract 24. Now if we add our like terms, I have a negative 2y, right, equals a negative 2. Remember, we're talking about old and new video games, and when you divide both sides by negative 2, y should be equal to 1. And now it's pretty easy to look at this, and so when the systems are kind of easy numbers like this, yes, you could probably have figured out in your head what these were. I need to see how you are doing it. I need to see the substitution. Just like when we did the 3 forms of equations, I need to see that you understand all 3 forms. So we've done graphing. Today we're doing substitution. We'll do this again on Monday. So is it pretty easy to see what x has to be without even maybe going back and replacing it? X has to be 5. So when we look at our solution to the problem, the solution was, as an ordered pair, if we look at that, our solution is going to be 5, 1 in this case. Now, and the reason being that we used x for the new and our old equation, but now we want to look at that answer as we look at that answer, and we want to put it and answer the question. And if we were answering the question, we would say we had 5 new games, because that's really what we were solving for. We really didn't even need this answer, y equals 1, right? It didn't ask how many old games, it only asked how many new games we had, since x was 5. The other way is then when you know, since we were solving, trying to find x was our new games, in this one, if we would have solved for y first, you would have had that equation being written as, if you would have solved this for y first, you would have had y equals 6 minus x, and you would have got the x answer right away. And if it's a story problem and they only ask you how many, in this case, new games did you have, you only have to get that answer of the system. You don't have to tell me this one because it's not really asking that, okay? So your assignment that you are looking at is that D3. D3 is in your textbook. It is page 375. It is 11 to 31 on. Once I have the problem down, I know this is my solution when I get done, okay? I am looking for an x value and a y value when I finish the problem. So every time, sometimes I'll have the students start and put that right by it right away. I know one variable is equal to. I know, in this case, that y equals 3x. That means I'm going to go to the first equation, and I'm going to write x plus. But instead of putting y, I'm going to replace it with what y was equal to. And y was equal to 3x equals 8. So I replace what y was. I now have a pretty simple equation with one variable. 4x equals 8. And most of you don't even need to show that division and say, oh yeah, x is equal to 2. And I have the first solution. wanna then choose either the first or the second equation, it doesn't matter which one. And now, you're gonna plug in x is 2. Go to the second one. You're gonna have y equals 3 times 2. Gives y is 6. Does that check? 2 plus 6 equals 8. It checks. I don't have to write out the check, but I can just look at that first equation and this solution of x, y, 2, 6,